Hey there. Welcome to This Explainer. Today, we're rolling up our sleeves and dissecting the invisible machinery of human language. You know, we use language literally every single day, usually without a second thought. But right beneath the surface of our casual, everyday conversations, there is an incredibly complex, highly structured system running the show. We're going to look at language not just as a handy tool for communication, but as a precise, almost mathematical machine. And to kick things off, we're starting with a very important piece of advice directly from the author of our source material.
And that advice is simply, do not panic. You are not expected to master these technicalities right away. Look, when you first peek into formal linguistics, it can seem incredibly intimidating. You're hit with precise formulas, brackets, and symbols that frankly look a whole lot more like advanced algebra than your typical English class. But our source text offers this brilliant reassurance. Linguistics has become so formal and mathematical because scientists really need explicit, detailed ways to describe exactly how we communicate. We're going to break all of this down step by step as a highly accessible system. So seriously, do not panic. We're going to decode it together. To really get why we even need such complex formulas in the first place, we have to ask a pretty profound question. How can we understand sentences we've literally never heard before? I mean, think about it. Every single year, hundreds of thousands of new books hit the shelves. If they were exactly the same as the old books, well, that'd be a massive copyright lawsuit waiting to happen. Yet, as native speakers, we subconsciously decode these endless new combinations effortlessly. How on earth is that infinitely generative power even possible? Well, to answer that, we've got to look at the underlying architecture.
Okay, so here is our roadmap for decoding this architectural blueprint. We've got 4 main stops on our journey today. First, we'll look at decoding the linguistic sign. Second, the 4 levels of language. Third, the merge operation. And finally, deep versus surface structure. Let's jump right into section 1, decoding the linguistic sign. What exactly is the basic unit of language? This is our first stop, understanding the fundamental building block of this massive communication machine. Drawing heavily from the foundational work of Ferdinand de Saussure, our text defines a sign as a pairing of 2 specific things. It's a quadruple pair that combines a tangible exponent, which is honestly just a fancy way of saying a sequence of letters or sounds, with a conceptual meaning, or what is actually being signified. Every single piece of language you consume is built on this exact pairing. Let's look at a really classic example to see this in action. Take the word dog. The literal sequence of letters, D-O-G, or the actual sounds we make out loud when we say it, well, that's just the physical exponent. It's the physical manifestation. But the mental concept of doghood, basically the set of all dogs in existence, that's the actual meaning. A sign system connects that raw physical exponent to that abstract mental meaning. Moving right along to section 2, the 4 levels of language, where we'll be dissecting the internal structure. Now, human language is infinitely more complex than a basic road sign or just a picture of a dog. So let's crack open this linguistic sign and check out the internal gears. In linguistics, a language sign exists simultaneously on 4 different levels. These are often called strata, or a quadruple. You've got phonology, which deals with the sounds or letters. Morphology, which zeroes in on the minimal parts that actually bear meaning. Syntax, which dictates the rules for how words get arranged together. And semantics, which deals with the ultimate meaning of it all. Let's see how this machinery operates in practice. What is really fascinating here is how a simple word, like dogs, operates entirely independently across all 4 of these mechanical levels at the exact same time. At the very bottom, phonology just sees the individual letters, D, O, G, and S. Moving 1 level up, morphology sees the base unit dog plus a specific S plural inflection. Now syntax doesn't care at all how that plural was formed, it just sees a plural noun. And finally, semantics looks at the meaning, a set of dogs that has more than 1 member. Every single word you speak is firing on all 4 of these strata, instantly. But hey, the machine definitely has a few quirks. While morphemes are the absolutely smallest units that carry meaning, like that dog and the S we just looked at, language also generates these larger structural chunks called idioms. Take the phrase, kick the bucket. The semantic meaning isn't literal, right? If someone passes away, they didn't literally go and kick a physical bucket. Yet syntactically, it behaves exactly like normal words. We can inflect it perfectly and say, John kicked the bucket. Language flawlessly juggles these weird little exceptions across its strata. All right, on to section 3, the merge operation. This is how the machine generates infinite meaning. Let's see how this whole system builds brand new, infinite ideas using a really cool mathematical concept.
To wrap our heads around how we generate completely new sentences, we kind of have to redefine the word grammar. According to our text, a grammar is essentially just a lexicon, which is your own mental dictionary of signs, plus a finite set of operators or functions. And the absolute most crucial operator of them all is something our text calls merge, which formal linguistics often represents with a simple bullet point symbol.
This merge operation is the exact thing that gives language its infinite power. Here's how the recipe works. Step 1. You take two separate individual signs from your lexicon, like the word this and the word year. Step 2. Apply the binary merge operation. Step 3. The grammar merges these two signs independently yet completely simultaneously across all four of those strata we just learned about: phonology, morphology, syntax, and semantics. Let's watch this actually happen.
The really crucial takeaway is in the exact merging process itself. When we merge this and year, notice how totally differently the various strata handle it. In the syntax layer, the machine formally combines a determiner and a noun into a brand new determiner phrase. But down in phonology? Phonology couldn't care less about grammar phrases. It literally just concatenates the strings of letters and slaps a blank space symbol right in between them. The operations are completely independent, yet they team up to flawlessly generate the phrase, this year.
And that brings us to Section 4, deep versus surface structure and all those hidden complexities. This is where we dive into the fascinating difference between the underlying hidden rules of language and what actually surfaces when we communicate.
Have you ever stopped to notice that the L sound in the word slight is physically pronounced quite differently than the L in the word listen? Seriously, go ahead and say them out loud right now. Slight, listen. The tongue placement and the airflow in your mouth are noticeably different, but as English speakers, we subconsciously recognize them as the exact same letter and the exact same sound. Why is that? Well, this perfectly highlights the difference between the physical surface and the psychological deep structure. A phone is just the raw, language-independent physical sound that's actually coming out of your mouth. But a phoneme is the deep structure psychological category that your brain uses to group those varying sounds together into one bucket. The surface reality is super messy and varied, but that deep structure, it's neat, tidy, and unified. We see this exact same structural complexity happening in morphology too. Just consider the concept of a plural. That is a single deep structure idea. But look at how wildly it surfaces in English. It can surface as an S in cars, it can surface as an een in oxen, or it can literally surface as absolutely nothing, like in the word fish, where the singular and plural are totally identical. One single underlying morpheme ends up manifesting as many different surface morphs. Now, these distinctions are incredibly vital because they show us exactly how this machine self-regulates. The underlying morphological representation contains all these hidden class rules. Because of these deep rules, your brain actively prevents you from ever accidentally saying Karen instead of cars or oxes instead of oxen. It's amazing. The hidden engine of language flawlessly governs the visible surface output without you ever having to consciously think about it. But all of this leads us to a truly fascinating final thought from our source material. As the author points out, if you look at the most perfectly formal mathematical level of this representation, the distinction between a surface morph and a deep morpheme might actually vanish entirely within the code. And that leaves us with an absolutely incredible question to ponder. Is human language, this beautifully complex thing we use every single day to express art and emotion, ultimately just pure mathematical abstraction? Well, that's definitely something to think about the next time you effortlessly merge a few words together. Thanks so much for joining me on this explainer, and keep asking questions.